Jonathan Truitt, talking to you about how to create your own control chart. Once you've created it, there are 4 steps to using it. The 4 steps are to enter the input cells, those are the green cells. So you would paste the frequency of the data and the data or the metric that you are measuring. You also want to enter the number of measurements in the baseline period. The yellow cells are auto-calculated, and once you have created them, don't touch them. You also want to make sure that the yellow columns are extended to equal length of the green columns. And you want to make sure that your data range for your chart captures all the rows. So you would have to either extend or shorten the columns in the graph chart as you use this Excel spreadsheet over and over. All right, so here we already have pasted the frequency per month and the metrics, and have determined that 12 is the baseline period. You will need to create in the graph, you will need to know what the upper control limit is and the lower control limit, as well as the baseline mean. So to determine the baseline mean, it's in column B. You would want to take the average from B10, which is 8.70, to, or which is B10, to an offset. And the offset is going to end up to be B21. The way you do an offset is you take A10 to A500, which is the A column. I chose to go to 500 in case I had that much data in. In this case, I only have 39 rows. And you would want to have the offset be G2 minus 1. So it would be 12 minus 1. So you would do 11 rows below B10. And you'd want to do it in the column 1 over from the A column. And then you have the height and the row height and column width for 1 and 1. So this would be from B10 to B21, and it says the average is 10.03. Let's just see if that's right. So going from B10 to B21, the average is 10.03. There are 12 cells in there, which is the baseline period, and this agrees with 10.03. In a similar fashion, you would do the standard deviation from B10 again to A21 in this case, because there's 12 measurements. So it would be offset from the A column, 12 minus 1. So it'll go down 11 rows below it, and you want to move over 1 column to be in the B column away from the A column. Once you have done this portion, you then move down here and you just enter that the baseline mean equals the same baseline mean, and you can just double click it and it'll go all the way down. The upper control limit is the mean plus 3 times the standard deviation, and the lower control limit is the mean minus 3 times the standard deviation. Again, you can take them both and just double click them down and it goes down. These 2 columns, baseline period and intervention period, are really just creating area graphs down here. So everything's a line graph except for these 2 values, which is an area graph, so I can just show you when the baseline period, when it occurs, and then when it converts to the intervention period. So to do this, I chose to have a value 1/4 the lower control limit, which is E10 divided by 4. This cell asks if G2, in this case 12, minus the count from F10, which is now locked, to a variable F10 that will change as you go down to F11, F12, etc., is greater than 0. So in this case, 12 minus 1 is indeed greater than 0, so you would enter the value of F10. Had it not been greater than 0, you would actually, this cell would be null, and that's shown by doing 2 quotation marks. This is very important to use the quotation marks instead of 0, as I'll show you in a second. So I just took this value and I would just double click it down and it goes all the way through. The intervention period asks the question if G2 minus the count of F10 to F10 equals 0. So in this case 12, and this here it's 1 minus 1 equals 0, which it does. It does not, I'm sorry, 12 minus 1 is 11, does not equal 0, so you don't enter F10, but you enter the null value. this row, it would be 12 minus 2, still not 0, so the null value. When you get to this point, it actually would be 12 minus 12, that does equal 0. So here you enter the F10 value, which is the 1.57. If I go further down and I show you this, even though I've anchored it at B10, all the cells, even they go beyond the 1.57, these null values do not count in the count. So it's still 12 minus 12, which is 0, so therefore you put in F10. Also, I wanted to determine the intervention mean. So I wanted to be sure we would enter the mean, which is the dotted line here, as opposed to the baseline mean to begin with. Want to know if the intervention mean, what it is, we would say is G10 not equal to null. And so G10 here is equal to null. So I don't put in the average offset, I put in the null value. However, down here, G10 is not null, so I need to put in the average for the post-intervention. And that's determined by, again, the offset function, this time in the front end. So I have the offset G2, offset from A by 12, not 12 minus 1. I want to be all the way down. One column over, so I'm in the metric column. And then I run it from to B500. So that would say, starting at B22, which is 12 down, is the average. The average is 8.15, and that's the same value I have here. So each of these cells is exactly the same, anchored in that fashion. So now you have your yellow box fit, you've got your green box, and you have your control chart, which automatically feeds it. Let's say you decided that you really wanted this mean value, the measurement period to be 21 months before the intervention occurred. Once I hit the enter, watch the blue and the green areas. They substantially change. The period of average changes because it's now only for the intervention. It doesn't extend this far back. The mean at the baseline also changed. Instead of being 10.03, it is now 9.48 because it is actually going down to down further. And your intervention mean, starting here, there we go, is 7.85, which is exactly what it says here. And if I was to take this one back up, since I obviously messed it up, I would get the 9.48, so to be 30. That's why I was going the wrong spot. So let me go back to 12, and the graph will again change, shifting over, and the value is the same. So there you've now can make a control chart on your own. If you play this slowly, you will see all the equations in that I chose to use. So you can copy and use those. Excuse me, and this, and this. All right, thank you very much. Have a great day.